As we start this lesson on powers and exponents, let's just review the definition of a variable. A variable is a letter that represents a number, and the value of that number can vary, hence the term variable. So a variable, an example could be n. N can be any number that you want it to be, or it could be x, or it could be a, or it could be the first letter of your name, whatever you want to use. It can be a capital letter, capital N, capital X, capital A, but it's usually a lowercase letter. We can think of multiplication as repeated addition. So if you have the problem 3 times 8, it's the same as 8 plus 8 plus 8, or 8 added 3 times. When you put variables, put a coefficient or a number in front of a variable, like 3, and then put n, that means 3 times n, 3 times whatever value n is, which would be the same then as n plus n plus n. So multiplication is repeated addition. Powers, however, is repeated multiplication. So if we had 8 multiplied 3 times, we could write that as 8 to the 3rd power. So the 3 indicates that we're multiplying 8 3 times. This is called the exponent. 3 is the exponent. And the number that's being multiplied repeatedly is called the base. So this is the base, the 8. I should have put it this way. That's the base. And 3 here is the exponent. Forget this part. So let's explore a little bit more with bases and exponents. If we have x to the 4th power, so we're introducing a variable here, this would mean that we're going to be multiplying x 4 times. So x is the base, and the number 4 is the exponent. We can say, if we have something like this, we can read it as n to the 2nd power, or n squared. So that there's a couple of numbers, actually 2. The number 2 can be read as squared, n to the 2nd, or n squared. And if you have something to the 3rd power, you can say a to the 3rd, or a cubed. But again, a would be the base, and 3 would be the exponent. On the TI-34 calculators, there's a power button. It looks like this, which would be, if I did use that, I might do it, say something like 10, and this power button 8, which is, could be read as 10 raised to the 8th power. It's the same as 10 to the 8th power. So this could be called, we call it a power button, but it can be raised to, put that in quotes. So 10 raised to the 8th power. And if you put that in, you would actually get a 1 with 1, 2, 3, 4, 5, 6, 7, 8 zeros after it, or 100 million. If you put 10 to the 9th power, oops, you would get 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, or a billion. So that pattern you can see when you have 10 to the 18th power, it would be a 1 with 18 zeros behind it. So it's a pretty predictable pattern. So powers of 10 can be very helpful in doing some calculations. Something kind of strange happens when you raise a fraction to a power. If you work it out, you'll understand why it works this way. But when you have 1/2 as a base, of course, you have a fraction as the base, and then the 3 means to the 3rd power. So it means repeated multiplication. So it's a half times a half times a half, which results in 1 times 1 times 1 gives you 1. 2 times 2 is 4, times another 2 gives you 8. And so you can see what happens. You start with a half, multiply it 3 times, and you end up with an 1/8. So you actually end up with a smaller value, which happens every time you multiply when you take a fraction to a power. Let's do 2/3 to the 2nd power. 2/3 times 2/3, 4/9, which is less than 2/3. So again, you take a if you take a number less than 1 to any power, the more times you multiply a number less than 1 by itself, the smaller and smaller the product becomes. So that's just a very predictable pattern also.